In this problem, we are going to find a strain transformation. So for this problem, we are going to have a chunk of a material that we're looking at, and we're going to say that we put strain gauges on this material, which is an image at the top left. And let's say we have a strain gauge, which is a sensor that measures how much strain you have in a particular direction. Let's say that we have a strain gauge oriented in the x direction and a strain gauge oriented in the y direction. And these strain gauges, which is what I just drew on the material, we're able to measure strain in x and y, with the strain being epsilon x is equal to 400 microstrain, which is written as epsilon x equals 400 times 10 to the minus 6, and epsilon y equals 150 microstrain, or 150 times 10 to the minus 6. And remember, strain is unitless. And we've defined our x and y axes with x being positive to the right and y axis being positive upwards. So given this information, we want to then transform this strain and calculate epsilon x prime, epsilon y prime, and gamma x prime y prime for a material that's rotated 60 degrees, a material element rotated 60 degrees in the clockwise direction with respect to the x-axis. Okay, so for this, we're just going to use the equations of strain transformation that were in the lecture notes. The only thing to be careful about in this problem is notice it asked for a rotation of 60 degrees in the clockwise direction with respect to the x-axis. So all that means is, and we'll draw it out just to make it completely clear, we have x positive to the right, y positive upwards. The material element's going to be rotated 60 degrees. So if this is our theta right here, and that's 60 degrees, so we'll have x prime and y prime. Just note that this theta is, the rotation is 60 degrees clockwise, but it's the way that we've defined our sign convention. This is actually theta is equal to negative 60 degrees when we use it in the strain transformation equations. And that's because a positive rotation with respect to the x-axis is in the counterclockwise direction. So just, that's one thing to note. We want to make sure that we have our signs right when we're plugging everything into the equations. But at this point, this is just a simply, let me draw the arrow there. From here, it's a simple and straightforward problem. We're going to plug in what we know into the strain transformation equations. So for epsilon x prime, our equation is that epsilon x prime is equal to epsilon x plus epsilon y divided by 2 plus epsilon x minus epsilon y divided by 2 times cosine 2 theta plus gamma xy divided by 2 times sine 2 theta. Okay, so for this situation of plane strain, we're saying that all we have is epsilon x and epsilon y. We're saying that there is no shear strain. So let me note that up here a ways, but we're going to also say that gamma xy is equal to 0. This is just something that's strained in the normal directions. Okay, so we have everything we need at this point. We just plug it all, and we plug it all into the equation. So we know what epsilon x is, we know what epsilon y is, we know what theta is, we know that gamma xy is equal to 0. So at this point, all this problem that's left to do is plug all of this into a calculator, and we'll get that epsilon x prime is equal to 212.5 microstrain, which is written as 212.5 times 10 to the minus 6. And now the process for finding epsilon y prime is no different. We'll just plug that into our equation, our strain transformation equation. So that's epsilon x plus epsilon y divided by 2 minus epsilon x minus epsilon y over 2 times cosine 2 theta minus gamma xy divided by 2 sine 2 theta. Okay, we'll plug this all into our calculator, which we won't do here just to save time. That's a simple thing to do. And we get that epsilon y prime is equal to 337.5 microstrain. So 337.5 times 10 to the minus 6. Okay, and then finally, and one thing to note here, now we're going to get gamma x prime y prime. We said that gamma xy was equal to 0, but when we rotate into a different coordinate system, so now we're expressing strains about a rotated coordinate system, now there actually could be a shear strain in that direction, right? So we have gamma x prime y prime divided by 2 equal to negative epsilon x minus epsilon y divided by 2 sine 2 theta plus gamma xy divided by 2 cosine 2 theta. Alright, once again, plug that into our calculator, and we'll get that gamma x prime y prime divided by 2 is equal to 108.25 microstrain. And then the problem asks for us to find gamma x prime y prime, so if we just multiply both sides by 2, then we'll get that gamma x prime y prime is equal to 216.5 microstrain. Okay, so fairly straightforward use of the strain transformation equation.